Yeah, so hey everyone, welcome to our aptitude sessions. For the first session, our topic is direction sense. Yeah, so when we talk about the topic called as direction sense, there is something called as the questions coming as a direction puzzle. They are given, the clues are given, you're supposed to understand, interpret them, and you're supposed to solve it. So, what exactly are you supposed to do, or how is your approach to the problem, an effective approach? That is, successive follow up of directions to be formulated, and the question asked will be to calculate the distance between 2 points. So, as and when you keep getting the clues, you need to follow up the clues. You need to, formulate them. That is, you really need to chart them out on a piece of paper or somewhere so that you can understand and recognize it. And as and when changes are going on, you will have to change the direction accordingly based on the magnitude. So there are two components. One is direction, that is in which side it is moving, either right, left, up, and down. We will call it with the compass direction, that is north, south, east, and west. And the magnitude, that is to what distance the person or the character, whosoever is in the question, to what distance they have moved. Is it 5 meters or 2 meters or maybe in kilometers or centimeters? The unit doesn't matter here. The distance or the magnitude actually matters. Okay, this is one thing. And coming to the cardinals, that is nothing but the four main points of the compass, north, east, west, and south. We have something called as ordinals or intercardinals. These are northeast, northwest, southeast, and southwest. So these, I think, are basics which are represented here on the screen. I hope you are fine with that. There is something called as secondary intercardinal. Okay, this secondary intercardinal is nothing but the subdirections of each of these. So what comes between north and northwest, there will be a bisector here, all right, that will be called as north northwest, north of northwest, north northwest. Similarly, what comes between northwest and west will be west northwest, that is northwest, that something that lies to the west of northwest, so west northwest. Okay, so similarly north northeast, east northeast, and so on. We can have 8 such secondary intercardinals, and you wouldn't need these secondary intercardinals as such, but for your knowledge of just for information I have provided here. And one thing you have to keep in mind is, if two opposite terms with same magnitude come together, they will cancel out each other. So let's say if the person or the character in the question is moving 5 meters to the right. Okay, so the person is here starting 5 meters to the right, and the person immediately goes 5 meters to the left. That is, it literally changes, comes in the opposite direction. But remember, magnitude plays a role. If they say the person moved 5 meters to right and 6 meters to left, then what happens? 1 meter towards the west that person has traveled. Okay, right is where your east lies, left is where west lies. So 5 meters they've come back, 6 meters to the left is 1 more meter towards west. So magnitude plays a very, very, very important role. Keep that in mind. Do not miss your magnitudes and directions. The second thing is, if two similar turns are coming together, they will lead to the opposite direction. So let's say the person started moving towards north. They moved 2 meters towards north. All right. Then they took a left turn. That is, they moved towards west. Let's say 5 meters to west. Then they moved 5 meters down, again left. So you're in west. Left of west is south. So you started 2 meters north. Okay. You moved 5 meters left. So now you are here. Which is your left? This side. This is your right, this is your left. If you turn this way, this is your left, this is your right. So if you're coming to the left, then what happens? You are moving down towards south. So where did you start? North. Now where have you landed up? South. So if two similar turns come, that means you're going in the opposite direction of what you started. That is two right or two left or two up or two down, either ways. Two of each. Fine. So yeah, let us say 4. When it comes to 4, what happens? You're moving back north again. You're moving in the same direction back again. You started in north, first left, second left, you started moving south, third left, and fourth left, you started coming back to north again. This much is clear? I hope no doubts. Fine. Okay. So the next thing is the distance from a particular point to another particular point. Okay. So you will have questions wherein the character has moved some X direction, some Y direction here and there, ultimately reached another destination. Okay. So the initial and the final position is there. You will have to calculate the distance between that. So most of the time it is always a triangle that gets formed, which is why this formula. Okay. So your base, that is nothing but your x, base is nothing but your horizontal distance. The perpendicular distance is nothing but your vertical distance. So x will be your horizontal distance, y will be your vertical distance, just like xy graph. All right. But remember here, x and y need not always mean the positive and the positive. It could also be on the other end, that is left and down, but we do not consider negative because real world we do not have negative. Okay. In the real world, negative doesn't exist. You do not have minus 5 centimeters on your scale. Just that, for example, or reference. So we do not consider it as negative. We will consider it with the direction. So if it is towards left, we consider west. If it is towards down, we consider south. All right. So this should be very, very, very clear. So that is how you're getting x square plus y square. Pythagoras theorem, hypotenuse square is equal to base. That is your horizontal distance square added with this one vertical distance. That is a perpendicular distance square. So you're getting hypotenuse square, but you need the answer of hypotenuse, not the square. So when you square root on both sides, you will get hypotenuse is equal to square root of base square plus perpendicular square. Okay. So understood the formula. In case you forget the formula, don't panic. Try to derive it this way. All right. One thing you have to keep in mind while you're solving the questions is always and always we will be starting here. I hope you can see the laser pointer, and this is exactly where we will start. That is, you are in between all of the directions. From your start, you will start moving up, down. From there, you will consider north, south, east, west, whichever it is. Clear? And usually the starting direction will be mentioned as either north, south, east, or west. If otherwise, it will be mentioned as up, down, right, or left. So this you will have to understand. In case you're getting confused, at the top corner, just make sure you're drawing the compass north, south, east, west. Mark it and then start following. Either that way or on the sheet of paper you want to draw it, pick and do. That is also fine. You're free to do. One more thing to keep in mind is the angle between these two directions. Angle between two cardinals is nothing but 90. They are nothing but in right angle, so 90 degrees. And the angle between a cardinal and its intercardinal is half of 90. That is 45 degrees. So the angle between one intercardinal and the other intercardinal, for example, northwest and southwest, what is the angle between them? Again, it is 90 degrees. 45 here, 45 here. So you're getting 90 degrees. So I hope these basics are clear. No doubts? All right.
No.
If so, okay, good. Then we will move forward. Right. So the first example, let's say a person is traveling for a distance of 7 kilometers towards east from his house. So what did I tell we actually do? We start writing it or we start formulating it. So let us say the person is here, the person is starting here, and the person has to move 7 kilometers towards east from his house. From his house, you don't have to worry. This is exactly from wherever you start is from his house. Okay. From there, east, 7 kilometers. All right. So 7 kilometers to the east. And then travels 7 kilometers towards north. So this is east. From here, you move north. That is 7 kilometers again. Then the person then travels 7 kilometers towards east again. So the person again goes 7 kilometers east and finally 7 kilometers to the north at the end. Okay, fine. So this is nothing but formulation. So this is his initial position. This is his final position. Okay. Now, what is the question? What is the vertical distance traveled by him? So what did I say will be your vertical distance? North or south will be your vertical distance. East or west will be your horizontal distance. So how many distance did he travel north first? Here he traveled 7, and here he traveled another 7. So 7 plus 7, 14. 14 kilometers. Everywhere it is mentioned as kilometers. But read the question, make sure it is always in the same unit. Usually it will be in the same unit, but be sure. It's always better to be sure of things. In case there are units, coming here and there, if there is a mismatch, let's say there is kilometer and meter, you'll have to start converting. Okay, so all these conversions of units will be dealing in quants. So by the time we reach there, you will know all of these things. Fine. Okay, so the vertical distance traveled is 14 kilometers. So what if the question was calculate the horizontal distance? What would it be? Again, 14. Why? Correct. Because this is your 7, this is your next 7. 7 plus 7, 14. Done? Cool. The next question. So a person is starting from his house and travels, okay, yeah, Sachin, he travels about 8 meters towards north, turns left and walks 6 kilometers. Okay, the person is starting here. So Sachin starts here and he walks 8 meters north. And what happens? He then turns left. So from here, his left is this side, that is towards west. And he walks 6 meters. Okay. Then he walks 3 meters towards south. From here, south is downward. This is 3 meters towards south. And finally travels 6 meters towards west. So yeah. And that is where he reaches his office. That is nothing but final destination. So this distance is 6. Okay, so this is the final destination. Yeah. So what is the distance between his house and office, and also find out the direction in which his office is situated with respect to his house. So the second part, that is the direction, is pretty easy if you're still confused. This is his house. So mark north, south, east, west. So this is his house. His office is in west direction. This is the final direction. Now you have to find out the distance between these two places. So can you notice that there is a right angle triangle that can actually be formed here? Okay, you might say you do not know this, but it is just 6. How do you get that 6 meters? He's traveled here 6 meters. It's going to be the same here. Fine. So if this was 3 meters out of 8, what is the remaining? 8 minus 3, 5. 5 meters. So you have 3 plus 6, that is 9. So your base is nothing but 9 square. And what is your perpendicular? 5 square. So add it, take the square root of it, you will land up in this answer, right? And so that answer is nothing but 13 meters. Landed up in the same answer? Okay. So then we will move forward. So coming to the third example that we have for today, that is starting from her house, Nisha traveled 8 meters towards west. Okay, so let's say her house starts here. She travels 8 meters west. Okay. Then turned right and traveled 15 meters. Okay. So from west, her right is nothing but up north. So this comes to 15. She then traveled 20 meters towards east. So this much is 8. So this entire thing is 20. Followed by 20 to the south. So from here till the point where she started is 50. Another 5 to the bottom. Yeah, that is where her hostel lies. That is her final destination. That is here. So this entire thing is nothing but 20. Okay, how far is her house from the hostel? That is nothing but this direction. Or this distance. Yeah, this distance. And the second part of the question is in which direction? Which direction? Pretty simple, east. Okay. Now coming to finding out the distance. So from 20, this much turned out to be 8. Right? So at the end, you can find it out. I hope. This is 15, this is another 5. So it's going to be 5 square here. This is going to be 12 square here. Oh, sorry. I shouldn't have mentioned square in the distance. Yeah. So let me know what is the answer you're landing up in. I'm sorry, I didn't hear you. Right. All of you landed up in the same answer?
Yes, ma'am.
Okay. Nidhi, I hope you also.
Yes, ma'am.
Okay, fine. So, most of your direction questions are pretty simple. The only variations they're going to ask you is which direction, distance between the points, and this one, the vertical and horizontal distance. These are the maximum variations I think we can ask. So I hope we have covered all of them here. Okay. So any doubts in direction sense? No? I want all of you to either unmute and tell or nod your head so I know what is happening. I hope all of you it's a no. You have no doubts. Okay, fine. Because once we complete the topic, we'll not be coming back due to lack of time. So now we'll be moving on to the next topic that was in the schedule. That is Venn diagrams. So when it comes to Venn diagrams, the questions require you to analyze and establish the relationship between the given groups or their elements. Okay, so there are two major or two broad classifications of Venn diagrams you can see here. That is relationship between the groups or relationship between elements of the group. All right. And so what exactly is a Venn diagram? It is nothing but a pictorial representation of a set theory using geometrical figures. So geometrical figures are nothing but basic geometrical figures such as circle, square, rectangle, or triangle. These things will be used. And each figure in this can represent a different group or a different set. So the various groups of, these are various groups. Each group itself is a set. Okay. Set of anything, maybe set of people who are interested in a particular field or set of people who belong to a particular profession or anything. It can literally be anything. Okay. It can even, the applications actually go up to plotting of things or analyzing things for real-time analysis. That can include in an office space how many people were interested to take up a particular certification, or how many people have passed a particular certification, or out of 2 to 3 certifications provided, how many appeared and how many passed, how many failed, how many appeared for more than one certification. This is just one example. So like this, it can extend to anywhere in real time. Fine. And while we are representing these Venn diagrams, the area which is common to two or more groups will represent the elements that belong to both the groups, common elements. So let's say we are having two groups, okay, a circle and a triangle as representation, for example. So let us say the interjoining area. So you have a circle and you have a triangle. The interjoining area of both these figures, what happens? It is representing the people who belong to both the circle as well as triangle, both put together, the common people. So common people will not be considered outside the common group. Common people will always be included in the common area. They will not be considered outside the common area. Fine, that number is restricted to that area. You will come to know once we start discussing further about it. You will get a clarity about what it is. So Venn diagram has three major types: type 1, type 2, and type 3. So type 1 and 2 goes for establishing the relationship between the elements. That is, groups are given. Between those groups, the elements what are there, between them, you will start analyzing the things. All right. Type 3, what you have, there are groups given to you, and those groups, you will start checking out what is the relationship, or you will try to establish a relationship between the groups whole as a whole. You will not try to consider the elements of the group here. The group as a whole will be considered. Okay. So type 1 and type 3 are not so commonly used, but better be prepared, and let's not leave out any topic as such. Type 2 is what exactly you have in mathematics as set theory. So for today's discussion, we will be taking type 1 and type 3. We'll be finishing them quickly. Type 2, we will discuss in the next session. It is a little more broad. It has a couple of formulae to understand and all of those things. So we will move to that in the next session. So type 1 and type 3, let us do it today. So coming to type 1, what is type 1? It is different figures for different groups. As I gave you the example, circle and triangle. So here I've put another option as well, that is rectangle. So the rectangle, this, this represents the group of actors. This triangle represents the group of singers, and the circle represents the group of dancers. All right. So now, what about people who belong only to this surface area? That is the area where only rectangle is there. There is no triangle, no circle, or no interjection of both or all the three. It is purely only rectangle. They are nothing but pure actors who are neither singers nor dancers. They are only actors. Okay. Similarly, when it comes to the triangle, the area where the circle or rectangle does not meet the triangle, this area is called as the group of only singers. Similarly, this group is the group of only dancers. So what about this area where rectangle and triangle, only these two meet? They are the group of actors and singers. What about rectangle and circle? Group of actors and dancers. And how about circle and triangle? Group of singers and dancers. And what about this area? The common joining area of all the three? Group of actors, singers, as well as dancers. Okay, they belong to all the three. Now, let us say 5 people are, all the three, that they belong to actors, the group of actors, singers, as well as dancers. So this region is 5. Let's say, for example, yeah. So this, let us say, is 5. And let us say that there are 3 people who are both actors and singers, just as an example. And actors and dancers, let us take only 1. But the total number of actors given is total number of actors given is 30, for example. So what happens? First, you will remove 5 out of 30. So what is left out for you? 25. Why are you removing 5? They're already placed here in the common group. You will always start from the group or from the place which is the interjoining or the interjection of all possibilities. You will start from there. Okay. So you will remove 5. So you're left with 25. Out of 25, you will remove 4. Why? 3 goes here, 1 go here. So 3 plus 1, 4, you will remove 4. So how many group of only actors are left out? 21. Okay. So this example is clear. This is the same with anywhere. So I give any other value, any other number. I hope you should be able to do it. Okay. So type 1 is clear for all of you. Yeah.
Yes, ma'am.
Okay. Yeah. So moving on to type 3. So what happens in type 3? Type 3, we will establish the relationship between the groups, as I told you. So you are given multiple groups. This requires a little bit of logical or real world thinking. You will really have to think that way. And that it all goes in accordance with that. So you're given multiple groups. You'll have to start establishing a relationship between them. Okay. So let us take the first example. All right. That comes to, yeah, animals, cats, and dogs. So do you find any relationship between these things? Yes. Is there something in common? Yes. That is the first thing or the basis for establishing a relationship. Is there anything in common or not? If it is not, you will put them as separate groups. If that is, if they have nothing in common. If they have something in common, what do? You will start seeing what is the relation, or to what extent what all are common. So fine. So cats and dogs, they both are animals, correct? But cats is a separate group, dogs is a separate group. I hope you'll be aware that it's distinctive as cat family and dog family. Lions, tigers, cheetah, leopard, all these come under cat family. Hyenas, wolf, jackal, fox, all these come under dog family. So it's very much different and distinguishable. So what you do is this. Yeah. So one set for cats, one set for dogs, but they both belong to the bigger set called as animals. So this will be for animals. Understood? So this is how you will start establishing a relationship. It can be of any form. It can be, 2 to 3 different sets having something in common. It could be all 3 to 4 sets having one being a part of the other. Okay, so one inside, one inside, one inside another. It could go that way. Or it could be entirely different. Given all groups are entirely different, they have nothing in common as such from the given list of groups. Remember, you cannot take anything apart from this. Just because you're thinking logically, you cannot add your own group here. Okay, so that is something you have to keep in mind, that we will come to the third example. Probably you will understand that. Yeah. The second example, that is month, week, and day. Does there exist any relationship or any commonalities between them? Yes. If yes, what are they? That is, week is a part of a month and day is a part of a week. So as I told, one inside one will come in. So you have the biggest one, that is month, as of what is given. Then you have week, which is a part of a month, and day finally, which is days are nothing but part of a week. So got it? One inside another has come. Okay. This is where I told you. So Mars, Earth, and Jupiter. Do they have something in common? Answer. Unmute and answer.
No. No, ma'am.
Okay. Anybody wants to tell a yes?
In terms of the planet, but there is no option for the planet, like whole 8 planets.
Okay. Okay. So
Solar
Kusum
system.
told no. Kusum told no and Sahana told yes. Sahana justified
I
why she
get
said yes. I want Kusum to justify why she told a no.
because the three of them are different planets, but they are a part of universe.
No, no, I didn't get you, Kusum.
No, because these three are different planets, Earth, Jupiter, and Mars. So there is no correlation between them, I guess.
Okay. So anybody else want to support or go against any one of them? I think Nidhi and Nandini, both of you.
I would say they don't have anything in common, ma'am, because all are separate planets.
Okay. Nidhi, what is your stand?
Same, ma'am. On a different planets.
Right. All are different planets. I hope if you remember, I had mentioned do not add something that belongs to this. That is not there in the question. Yes, of course, they are planets. But have I mentioned that group? When it came to cats and dogs, I had the group mention animals. If I didn't have animals there, I will not be able to establish that relationship. That is what I told you. When you start thinking logically, yes, this is a very natural tendency to do this, but make sure you're not doing that. Observe the question multiple times, read it twice, thrice, 5 times if required. It's okay. It's all worth a right answer than thinking about how tedious it is to read the question again and again. It's all right. Read it, confirm it, and then make sure that you are reaching to the right answer, or your approach should be that way. Okay, so these are all different planets. I have not given universe or planet or galaxy or Milky Way. I have not put anything here. So there is no other group that can establish the commonalities between them. So they will be kept as 3 different groups as Mars, Earth, and Jupiter. M, E, and J. Okay. So I hope things are clear till here. You guys have any doubts? Do not worry about the time. We can schedule another meet if required. Sure, you have no doubts because we will not be revisiting this again. It will directly be your weekly tests. Okay, fine. So if I twist the questions in any way, I hope you'll be able to solve. Okay, because I've tried to cover most of the variations possible in all the 3 categories, that is direction sense, type 1 and type 3 Venn diagrams. So type 2, it will take a longer time, which we will not be able to cover today. So we will definitely move to it by tomorrow. Fine. And as you guys requested, I will be giving you questions on the WhatsApp window. You can receive the questions and practice for today. So I think 2 per topic I'll be giving you. All right. That is fine.
Ma'am, in
Yeah.
case we have any doubt in the questions, should we wait for tomorrow's class and, ask you in the class, or is it
Not
fine to
needed.
ping you on WhatsApp?
You can ping me on WhatsApp. I would prefer you to ping in the group so everybody whosoever has a doubt similar to it is clear. And even if otherwise, they are having better clarity. Okay, so as I mentioned before,
Okay.
ping me personally only when you have something really personal to share, which is not common in the group.
Okay, ma'am.
Fine with all of you? Okay. So fine then. Thank you for joining today's session and let's meet in tomorrow's session. Bye-bye.
Thank you so
Thank
much,
you,
ma'am.
ma'am.
We had a great session.
Thank you, ma'am.
Yep.